All right, we're going to evaluate logarithmic expressions. So here's our problem. We're going to evaluate log base 4 of 16x to the third power when x is 256. So it is wise to split this up according to your properties of logarithms before you just shove 256 in there. So first thing would be to bring your power out in front. I also went ahead and split this into a product right here. So 3 times log base 4 of 16 plus log base 4 of x. Here, next step, I plugged in 256. Then I went ahead and solved. Log base 4 is 16. Think about 4 to what power gives me 16? That's 2. 4 to what power gives me 256? That is 4. So we would have 3 times 2 plus 4. Order of operations, you can simplify or distribute, it doesn't matter. You get 18 as a final answer. Another one, natural log this time. Natural log of 7e squared. Again, pull out your power, split it up as a product. Natural log of e is 1. So we have 2 times the natural log of 7 plus 1. Natural logs are not as commonly known because e is an irrational number. So you're going to have to use your calculator. But natural log of 7 comes out to roughly be 1.95. Add that 1 from our natural log of e, and you get roughly 5.89 as your final answer. Okay, this one has a couple more steps. So we're going to evaluate our following logarithm when x is 1,000, but we need to change it to base 10. The directions tell us to change it to base 10, but changing these to base 10 makes it a little easier to solve without a calculator as well. So here's our problem. Log base 100 of 10x squared. Pull your power out, so it becomes this. Now, changing the base to 10 means we're going to have to use our change of base formula from a couple days ago. So it becomes 2 times log of 10x over log of 100. Okay, our numerator now is a product, so we can split that into an addition. So log base, or 2 times log of 10 plus log of x. I went ahead and substituted my 1,000 in now. So x was 1,000, plug that in here. 10 to what power gives me 10? Well, that's 10 to the first. 10 to what power gives me 1,000? That's 3. 10 to what power gives me 100? That's 2. So we plug in all those numbers. We have 4 over 2, which is 2. 2 times 2 gives us a final answer of 4. Here we're going to evaluate when x equals 6, and we're going to change our logarithm to base e, so we're changing it to a natural log. Here's our problem. Pull out that exponent, use a change of base formula. That change of base formula uses, it can be used with logarithms or natural logs, so same idea, just this time we're changing it to base e, which is a natural log. So natural log of 2x over natural log of 4, still all of it times 3. Here I went ahead and plugged in my 6, and it's a product, so it gets split up. And then again, all of these natural logs are hard to know off the top of your head. You won't be expected to know those. So type those into your calculator. You should get on top roughly 2.485, on the denominator 1.386. When you simplify that, you should get about 5.3774. And lastly, we're going to take this 1,000 to the 9x equaling 100, and we're going to solve for x. So we want to know, what is our exponent going to be? So here's our problem. If you recall, our inverse property for exponents tells us that if we take log base 1,000 of this thing, the log base 1,000 and our 1,000 as our base cancel off. What I mean is doing this. So log base 1,000 of 1,000 to the 9x. It's an equation, so just like our basic algebraic equations, we have to do the same thing to both sides of our equation. So if we take log base 1,000 on the left side, we have to take log base 1,000 on the right side as well. Okay, the point of that is to cancel these off, leaving us with 9x on the left side. We need that variable, that x, out of the exponent. So we have to do the inverse. Well, in this case, our inverse is that logarithm. Because, again, recall, inverse of an exponential is a logarithm. So log base 1,000 of 1,000 to the 9x, those cancel off. We're left with 9x equaling log base 1,000 of 100. Now, again, we don't generally do things with log base 1,000. It makes more sense to change it into a common log or log base 10. So use change of base formula here. That becomes log base 100 divided by log base 1,000. Since these are powers of, or factors of 10, multiples of 10, it makes it easier to simplify these. So log of 100 is 2, log of 1,000 is 3. So now we have 9x equals 2/3. So we've made this fairly complicated equation down into a one-step algebraic equation. We would divide by 9 here. We do not divide fractions. Instead, we multiply by the reciprocal. So that becomes, if you divide by 9, we have x equals 2/3 times a ninth. X is 2/27.